Hey guys, welcome back to my YouTube channel. My name is Bhanu Chandra and I'm studying in Sri Venkateshwara College of Engineering. I'm a second year student of engineering and my branch is computer science engineering with specialization of data science. My USN is 1VE23CD007 and today's subject is data structure and algorithms. The subject code is BCS304 and today's topic is simulating a airport runway using priority queue in the concept of data structure. So what is airport runway simulation? So it is a simulation model made by using data structure concept for making airport runway operations such as landing and takeoffs. So it helps in scheduling planes efficiently while avoiding conflicts like two plane scheduling to the same route at the same time. So we are using data structure and algorithm in this concept because queue and priority queue are ideal for handling such kind of real-time processes. So objective of this project is simulate a single runway airport, managing operations like landing and takeoff, prioritize safety, which is emergency landing should take priority over regular operations. So we should make a priority queue in which emergency landing should be given the first priority, then other landings and takeoff. So efficient scheduling. So it reduced waiting time for planes and optimized runway usage. So here data structure, uses of data structure in this program is queue. It stores regular landing and takeoff request, which is in and first out order. And the priority queue handles emergency landings by assigning higher priority to the emergency landing requests and giving the low priority to the normal landings and takeoff requests. So this is the algorithm for the program. So for step one, we'll initialize the landing and takeoff sequence of the queues. So we'll initialize two different queues in which the elements will be the planes which are going to be landed and the ones which will be taken off at that point of the time. So the next step is simulate time in discrete increments. So we'll assign a certain time for one plane and we'll increment it with the desired amount of time. So which gives the uh, data of the next plane which is to be landed or which is to be taken off from at that point of the time. So step 3, we'll check if there are landing requests in priority queue and we'll process emergency landings first and followed by regular landings. So in the priority queue, we'll assign the emergency landing as 1 and other normal landings or takeoff as 1, 2 and 3 so that if there is any emergency landing, it will be continued as first priority. So step 4 is if no landings are pending, we'll handle takeoff requests. So after all the planes have been landed safely, and next we'll proceed to the takeoff request. So step Y will update runway status and log the complete operations. So we'll see whether there are any planes that are to be taken off and will that are to be landed, and we'll log it in complete operations. So step 6 will repeat until the simulation is ended. So I've created a program for this airport runway scheduling in C language using VS Code. So this output demonstrates how priority is given to the emergency landings first, followed by regular operations. So this will demonstrate the usage of priority queue in uh, real-time programs like this scheduling operation. The program for airport simulation modeling is this one. So we start by including all the header files required for the program. So first one is stdio.h. This is used for all the input output functions like printf and scanf. So stdlib.h, this is standard library used for dynamic memory allocation functions like malloc, this one. So then string.h, this is used for string function. So starting the program, first we create a structure for the plane where we create plane ID priority. We give the priority based on number integer. So higher the priority, lower the number. Then we create a pointer in which it points to the next plane in the queue. So next function is to create a new plane node. So here we dynamically allocate memory during the runtime. So we ask the console to give the runtime memory. So here dynamically memory is allocated and that the memory which is allocated is copied and priority is set based on what the memory is given. If the it initializes the next pointer to null if there is no plane in the next of the queue. So the next function is to insert a plane into the priority queue. So here, if the lower the value, higher the priority is done here. If the head node is equal to null or the new plane has higher priority than the head node, it becomes the new head node. Otherwise, it traverses the queue to find the correct position to insert a new plane, maintaining the priority order. So from lower the number, higher the priority. It links the new node to the appropriate position in the list. So next one is next function to process the plane at the front of the queue. So here it checks whether the queue is empty or not. If the queue is empty, it will show a appropriate message that no planes to process. And if the queue is not empty, it will print processing message and it will show the ID of the next plane that has to be taken off. After the execution of that, the free statement is used. It is used to deallocate the memory which is allocated during dynamic memory or memory allocation. Here, malloc function is used. Anything that is allocated using the malloc function, the free thing is used to deallocate those memory. So the next part of this program is to print the remaining planes in the queue. So after the priority is set, the remaining planes inside the queue has to be allocated for the takeoff path. So this function is used. It will print the message remaining planes in the queue and print all the planes inside the queue based on the priority. So now we enter the main function. So in this part, there is an empty queue is initialized and all the above function is induced in this main function. Here the output functions are displayed. So we after processing the console, all the data which is accepted from the console, it is printed here based on the priority queue. Then after that, the output is printed. So if we click on the output here. So as you can see here, this is the output of the program. So runway simulation log processing plane A. So plane A is emergency landing, so it is given the first priority, and this is in the first of the queue for landing. So plane B is regular landing, so which come since A is first priority, it is executed first and then B. Then after all the landing process is completed, plane C is there for takeoff. So plane C is given as takeoff processing. Then remaining planes is displayed. In this case, only three planes were there. So remaining planes in queue is not displayed here. So that's it for the program. So continuing with our So now few advantages of using DSA for this simulation projects are listed below. So efficiency. So it quickly processes requests without any manual interventions. So there will be fast processing of the request without manual interference. So it helps in reducing the number of personnel working in the airport. And the second one is scalability. Can handle more planes and runways with minor modifications. So a whole organization or a whole system can be run using a small database or from a small place inside the airport. So next one is accuracy. So minimize scheduling errors and ensure better management. So it minimizes the errors which may lead to problems like two or more planes routed in the same path. So which increases accuracy. So challenges and limitations for this program is so simplified assumptions. So real world scenarios include more variables like weather, air traffic and many other things. So which cannot be induced in same program which leads to increasing the size of program. So which is not favorable for the airport management system. So single runway constraints limit simulation to a small airport. Static operations, simulation does not account for real-time request modifications. So here Once a signal is given for landing or takeoff, that cannot be modified based on the real-time monitoring. So if a plane is to be landed, but for some situation now it is not going to land, then the system does not change the schedule for not landing. It will be remain for landing. So concluding today's topic, so airport runway simulation demonstrates how DSA can be used to simulate real-world scheduling problems. So efficient resource utilization and improves operational safety. So with future enhancements, integration with real-time data and dynamic operation, this program may support multiple runways at a single time. So that's it for today. Thank you for watching my video. Make sure to like my video and subscribe to my YouTube channel for more content. You can comment your doubts below. And as for the code for the simulation, I'll give it in my description box. You can use it. Thank you for watching.